Hey guys, welcome back, and today we are going to be getting into 6.3, which is graphing sine and cosine functions, which is what your pretest was kind of on. And so for the thing slash form, I have what happens when you evaluate f of x equals sine of x. Go around the circle, and when I say the circle, I'm talking about the unit circle. So let's sketch. Might not be the greatest because I'm using this little tablet. So that's actually pretty good. Right, so sine of x, remember, for a point x, y in that unit circle, we said that y was the sine of x. I'm not going to get into the reasoning for that again. But notice that the highest y value we go is 1, and the lowest y value we go is -1. So sine of x stays between -1 and 1. And notice we have repeat answers too, right? The y value here is going to be the same as the y value here. Likely the y value here is going to be the same as the y value here. And then if we did cosine, let's just think about cosine x for a second, right? Kind of the same thing, right? Cosine is the x's, remember? And again, I'm not going to go through why that is once again, but the farthest we go on the x's to the right is 1, and the farthest we go to the left is a -1, right? So again, cosine of x stays between -1 and 1, right? Because it's just these x values. And again, these values repeat, right? Here and here. We have two repeating x values, right? Two repeating x values here and here. And we'll get into a little bit of what that is like, for what that means for the graphs of sine and cosine. And so here's a definition where I have something that is super mathy, right? So a function is periodic if for some real number alpha, f of x plus alpha equals f of x for each x in the domain of f, blah, 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 blah. What is this saying? This is saying is if you add alpha to a function, and the function just ends up looking the same, right? If you add alpha and it just looks like the original function anyways, then it's periodic. And, in not so mathy terms, that essentially just means that you have a repeating pattern in a function, right? If every alpha you add, it looks the same, then you have a repeating pattern, right? And we can kind of think about that with sine and cosine and angles, right? Every time we add 2 pi, we're back to where we started, no matter where we're at. If we're here, if we add 2 pi, it looks the same. If we add 2 pi, it looks the same. If we're here, add 2 pi, it looks the same. Or 360 degrees, right? And then the least positive value for alpha for which this is true, this is true where it looks like a pattern, is the period of the function. And so that's just the length of the pattern is considered the period of the function. And so the graph of f of x equals sine of x is periodic, and the period is 2 pi. So what's that saying? So it's saying the graph of sine of x repeats, which kind of makes sense, right? If we were just to go around that circle and we were to start going around that circle again, we would get the same values over and over and over. And every length is 2 pi, right? So we go around once, that's 2 pi, that's the period, then we start everything over again. And we can kind of see that when we actually graph the values, right? So if we were to actually graph like the sine of like pi over 2, which is 90 degrees, you get 1, right? And if you were to graph every angle in between there, all the way up to sine of 3 pi halves, which is 270 degrees, which is -1, right? This is what you get, and then you keep going, and this goes on forever and ever in both directions. And we'll notice that the sine is, so let's look here. We're at -2 pi, right? And then when we add 2 pi, we're at 0. And then look, at another 2 pi, we go the same. So that also explains why the period is 2 pi, because after 2 pi, it repeats itself. And so a couple things to note here is that the zeros, and this is stuff that up here I say you should most definitely, certainly, for sure, no doubt, write this down. The zeros are at pi n, or they're at every pi, if you notice. So what pi n means, when I say n, I'm saying n is an integer. And so what pi n means is just at any value where it's just pi, right? N is just saying 2, 3, 4, 5, or negative 2, 3, negative 800, right? At every value of pi, right? At pi, at 2 pi, at negative 1 pi, at negative 2 pi, negative 3 pi, and at 0, right? If n is 0, we're going to be at a 0 for this. And then we'll notice that we have these maximums, right? It's kind of hard to see without a larger snapshot, but these maximums, which again are at x, or we're at y equals 1, is going to be, well, here's one at pi halves, right? So let's write down pi halves. And then where are all the others going to be? Well, there's going to be one up here, and it's going to be after the function repeats itself. So after you've added 2 pi, right? And we can kind of see that here. At negative 3 pi halves, after we add 2 pi, we'll be at pi halves. So it's after you add 2 pi, right? But you can add 2 pi as many times as you want, or you could subtract it. So we're going to stick n on there, which just says any integer, right? So all that n is saying, add 2 pi as much as you want, or subtract 2 pi as much as you want. That's where your maxes are going to be. Now, our minimums are going to be, we're going to do a similar thing. We could start at 3 pi halves, right? And then again, anytime we add or subtract 2 pi as many times as we want, we're going to get another minimum. So that's that one. For cosine of x, same thing. It's periodic, right? Because we go around that circle, and every 2 pi it starts to repeat. So it's periodic with 2 pi. And now you'll notice it almost kind of looks like the sine function. Like kind of here we do have the sine function, and it actually is. It's just moved over pi halves, right? So here, let's just take note of the properties of the graph here. Here the zeros are at pi halves, but it's not every 2 pi, right? Look at this. All we've done here is add pi. We're only adding pi for these, so plus pi n. So they're at pi halves. Basically, any pi where you're going to have an over 2 at the end is what that is saying. And now the maxes are actually, the max and mins are kind of nice. Notice that the maxes on the cosine function are just at, here we have one at 2 pi, here we have at negative 2 pi. If we were to see this in a broader context and at 0, it's at every even pi is how I'm going to write it. Every even pi, right? So 2 pi is even. At 4 pi, we'd have a max. At 6 pi, we'd have a max. At negative 2 pi, we'd have a max. Negative 4 pi, negative 6 pi, negative 8 pi, right? And 0 is even 2. So at every even pi, we have a max. And then at every odd pi, we have a minimum, right? So at 1 pi, 1 is odd, we have a minimum. Negative 1, we have a minimum, right? And if we were to keep going, at 3 pi, we'd have a minimum. At 5 pi, we'd have a minimum. At 7 pi, we'd have a minimum. At negative 3 pi, we'd have a minimum. Negative 5 pi, we'd have a minimum. So on, forever, in both directions. And just to kind of visualize this for us here is the sine of x, right? Here's our up and down. And we have our zeros at these pi's and all that we just said. And if we scroll out, see how this just keeps on going forever and ever. But it doesn't go any higher up, right? It's bounded between negative 1 and 1. And so now, let's type in cosine of x just to get the same idea, right? Now it's the same thing, right? We have our maximums at every even pi, right? Here we have 6 pi, 4 pi, 2 pi's, and so on, negative 10 pi. Right, minimums at odd pi's, 1, 3, 5, 7 pi's. And again, you scroll out, and it just goes on forever in both directions, right? Because we're just repeating ourselves on that unit circle. And just to see what they kind of look like together, here's what they look like together, right? Again, like literally the same thing, except this is moved over pi halves, right? If this is pi, halfway is going to be pi halves. So it's just kind of scooted over pi halves from each other. Just something to note. And so when we are sketching the graphs of sine and cosine, this is something that we need to get used to. Like, this is something you should write down. So when we're doing sine of x, and this is because graphing this thing is something that will help us like so much in identifying values, right? So we have we have the triangles and we have the unit circle, but I think visualizing this graph, once you get used to understanding the graph, at first you might be like, man, this is crazy and there's no way I'm going to memorize this. But after you've used this graph literally just a couple of times, it will stick in your head like glue and it'll be so easy to tell the values. So a full period is 2 pi, right? And I like to cut that in half, so half of 2 pi is going to be pi halves. Then I like to cut my halves in half, so 3 pi halves and pi halves, right? And this makes sense, right? Half of pi to 0 is going to be pi divided by 2. Now this, halfway between pi to pi is a full pi, right? So in between is going to be pi halves. So what we really have is pi plus pi halves, which is the same thing as 2 pi over 2. 2 pi plus pi is 3 pi all over 2. So that's why that's 3 pi halves. And this is just something we should memorize. We start at 0 here, and then remember our max was 1 and our minimum was -1. So our max is going to be 1, and then we come back down, and then we go down to our minimum, and then back up to 0. And then it's kind of a horrible graph, but you guys just saw the pattern of it, right? And you should think that every tick mark that you've been to, you have to make a stop, right? So at this first tick mark, we can call 0. We were at 0. At this pi halves tick mark, we had to go up to a maximum. Then at the next tick mark, we were at a 0. At the next tick mark, we were at -1. At the next tick mark, we were at 0. You should never be jumping, right? So from this tick mark, a lot of people will want to go to -1 down here at this one, but just remember that you have to stop at 0 first between every tick mark. Or no, between every, like you have to make a move for every tick mark. That's how I like to think about it. And then cosine is going to be very similar. Cosine of x is just going to be, again, we're at 0, and we said our maxes were 1 and -1. Again, our period is 2 pi, and I'm going to cut that in half, and then I'm going to cut my halves in half. And this is 3 pi halves for the same reason. And again, this is something that you're just going to want to just straight up memorize. The cosine starts up at 1 at its max. Then every tick mark, we have to go somewhere meaningful. So this tick mark, we're going to go down to 0. This tick mark, we're going to go down to -1. This tick mark, we have to come back up, right? Because we're not going to pass -1 and hit there. And then at this tick mark, we got to go back up to 1, right? I'm going to do my best job to sketch this. It's not going to be great when I'm on this tablet, but and it shouldn't look like a parabola. It should look a little more swirly, but it's kind of hard on the tablet. And these two things you should definitely write down, and you should get used to graphing these in your head or on paper every time. Like this, after doing this lesson, maybe you should just like write down these graphs 3 times each, because this is something that you just want to straight up know. Like if I say graphs the first period of sine of x, you should just be like, this should take like a second to do. Like this should be like bang. So get used to doing this. And the reason this is really helpful, right, is because if I say, hey, what's sine of pi, right? And instead of sketching a unit circle, what a pi is 180 degrees, sine is the y value, that's going to be 0. If you think of this graph in your head, right, sine of pi, oh, I know that crosses 0 because I know that my tick marks are pi halves pi, 3 pi halves 2 pi, sine of pi, 0. And you might be like, well, that's kind of crazy to remember that. I'd rather do something else, or just but again, I think you'd be surprised how quickly that once you work with this graph, you will catch on to the fact that pi, or of where everything is at, and just memorizing it. So and at least for me, and right, I'm a math major, right, I just went through a bunch of rigorous math courses. This, whenever I had sine of pi on a test in math in college, right, this is what I did in my head. I didn't do the unit circle. You can't do any triangles. This is what I did in my head, right? Same thing with cosine. This is what I did in my head every time. So this, if you're moving on to calc, or if you're going to college and you are using anything, if you have to take a calculus class, even if you're not a math major, most STEM careers you have to take calculus 1 through 3. You're going to need this is going to be super helpful. So there's not really any homework assigned with this stuff. My homework is going to be like literally just write these, draw sine and cosine, and know the differences between them, and know the tick marks. That is your homework. Is know these two, right? So, um, just for the sake of your future, you're going to want to know these. We'll get into some examples using them in the next video.